students. Today I'm going to be talking about a really interesting topic that has to do with the part of physics and motion. Can you guess what it is? Oh, I think I gave the answer away. But anyways, we're going to be talking about buoyancy and the Archimedes principle. First, we'll be talking about buoyancy because Archimedes' principle is just a step further of explaining buoyancy. So first, buoyancy is something that determines whether an object will sink or whether it will stay afloat or whether it will have sink or half float. Now there are three types of it, and that's how you can measure it. It's the positive, negative, and neutral. I also have diagrams which I will explain. The positive one is where it will float. The negative is where it will sink. The neutral, where it's half floating, half sinking, more or less sinking. So, let's get into our diagrams. A negative, let's say we use paper. The paper is floating, but keep in mind the paper does get wet because of the water. Soon, it will sink. So the main part is sometimes the object won't stay in a positive form, in its negative form, or positive. It can get transformed, which is why buoyancy is very special to study, and I love it. So paper is a very special example of it because it was positive, but as it gets wet, it gets more and it gets transformed to negative. Hence, it will sink. So that's an example of it. Now, negative, specifically negative, and it mainly cannot transfer because it's already sunken. So, we can use a screw, a metal screw, for example. When you drop it in the water, its weight and its volume and its density will make it sink. Keep in mind, friends, that buoyancy is determined, which is how it is determined. It is determined by an object's density and its volume. If it's denser and it has less volume, it will be positive buoyancy. If it has more than the water or more than the air, for example, because remember, airplanes float in air, cruises, ships float on water. So water and air are a big matter of it. But get going. Let's say we have a negative one, right? The screw. It's really important that we also know neutral. But neutral, the thing is neutral, I said, some of it would be half sunken and half floating. That's in my example right here, you'll see later on. Let's take an orange, which I will be it's diagrammed and I will be showing it live. The orange, when you put it in without its skin, it will sink. It will be negative because the water gets absorbed. But if it has its skin, keep in mind that the skin is like a shell for the orange. So the water can't get in. So it would be neutral because some of its weight can make it a little bit denser, right? So it can't be exactly positive. It will be neutral. Half sinking, most part of it would be sinking. And still, because a little bit is floating, we count it as neutral, not negative. So now let's do the example. So these were our diagrams. And I will also be pointing out Archimedes' principle later on. Okay? So we have our bowl. Keep in mind it should be full of water. And we have our orange. For example, this one, I didn't peel the skin because obviously it would have rotten. But let's say I put it in. You see a little part of it is floating. So that's why we have to say it's partly positive. But keep in mind that, see, most of it is negative. But because both of them are in there, we would say it's neutral or normal as an average. Now we will be pointing out Archimedes' principle. Yes, you know Archimedes, the Greek mathematician. But how did he even point out all of this? So everyone takes a shower or a bath, right? He went into his bathtub and he noticed that when he went in, the water rose. This goes and it shows a step further. Let's say I have this in here. You see, we can even put our hand in later on. So you see, I put the orange, but did you just see? The water increased like tiny bit. Now let's show a bigger impacted example. I have it in my hand. Did you see that? It even sank a little. See, it's almost gonna overflow. So Archimedes had pointed this out, and only what it shows is that it's a step further. But what Archimedes' principle is that it points out the weight can almost be equal to what's out. Let's say we have another example. This one we'll have to think because it's really hard to say. Let's say we have a jug with a tap, and let's say we have a 5 kg rock, and we put a scale. When you put it in the scale, yes, it shows it's 5 kgs. That's simple. What does that have to do with Archimedes' principle? Step 2, put that in the tap, and we'll see it will overflow, but it won't exactly overflow because let's say we have a smaller container. In the smaller container, the water from the jug, since it will overflow, will go through the tap in there. And then we will also see, once we see the rock's measurement with the water, it's not 5 kgs, it's about 2.5. So whatever it's there, about 3, we can say that is the measurement of the one that's in the smaller container. So this is all for buoyancy and the Archimedes principle. And remember, they are not equal. Archimedes' principle is a step further reasoning and an explanation of buoyancy. If you have questions, put them in the comments below. Like and subscribe to my videos if you like them. And if you really like them, please subscribe and like. Bye friends, see you soon. I hope to answer your questions.